Hello everyone, welcome back to the Swift Academy. In today's video, we are going to solve another Leetcode issue that it's so popular among the interviewers. It's called two-sum and also it categorized as an easy question. But regarding that, it is easy because simply you can find the answer for that. It is so important how you communicate with your interviewer, how you describe the things to your interviewer, how you are going to solve this solution by the brute forcing solution, then you are going to use another approach, then your third approach, and you have to talk all the time with your interviewer about how you are thinking. So please think loud and talk about how you are going to solve the problem. Even if the interviewer give you an easiest question, it is going to find how your thought process is. So bear with me, I'm going to describe this question to you. This is two-sum. It will give you an array of the norms and it is going to finding the target. But what is the target? There is only two number or integer inside that array that if you add them together, the target value will be the things that the question asking for. So for example, in this question, we are looking for the target 9. And if you look at the norms, the array, you can find out, okay, at the index 0 and at the index 1, 2 plus 7 is equal to the 9. It means that we have to return just the index of those numbers that when you add them up together, you will have the target. Okay, the brute force approach that you are going to think about it is to iterate through the whole array inside a two loop and just seeing that if the value 1 adding to the next value is going to be our target or not. But we know that when we are going to use two for loops inside together, we are going to have the time complexity of O(n) square, which is not so good. For example, if you have a long list of the array and you have a bunch of numbers here, if you are going to iterate, for example, 1 million numbers, what will be happen? In the case of the time complexity, it's not going to be worth you a lot, because always you have to design an algorithm that is so efficient. So let me describe how we are going to solve this problem by using a little bit of the space in memory. Okay, now take a look at this example. We have an array consists of the bunch of numbers here, and the question will be asking us about to find the two number or two digits that when you add them together you are going to have 14. So if you are going to using the first approach, the brute force approach, we ended up with the two for loops that which is not actually so efficient. So we are now going to use another methodology that we always using that inside this kind of the questions. Guess what? We are going to use the hash maps. You know that inside the hash maps, when you are inserting something into it, the time complexity is going to be O1, and when you are retrieving data from that, it is going to be O1 as well. So inserting or asking about one value inside the hash maps, the time complexity is O1. So by the help of the hash maps, we can actually solve this problem and iterate through whole the list just one time, but we sacrificing the space for that. So the whole time complexity is going to be O(n), and it means that we can actually iterate through whole the list just one time. It's about the time complexity, but in case of the space, at the worst case scenario, we should sacrifice it the whole list and it will be O(n) as well. So the time complexity reduced to the O(n), but we, with the help of the space that we are using, we are going to O(n) time complexity. Let me explain how we are going to use hash maps for solving this problem. We are going to use just one for loop here, And on each time that we are visiting one of those numbers or indexes, first of all, we are going to ask our hash maps, do you have the difference between those target and the index object that we are actually looking for? For example, when we are in the index 0, if this is our hash maps, we have the key and we have the value. If we are at the index 0, what will be the difference between them? 14 minus 2 is going to be what? Is going to be 12. So we are going to ask hash maps. As you can see, we already have 12 in our list, but we are at the index 0 now. So at the index 0, we still didn't see the 12 that exists there. So we are going to add 2 inside our hash maps, and the value is gonna be the index of the value. So 2 is gonna be at the index of 0. Then later on we are going to do the difference between the 14 and also 3. The next index is gonna be 11. We are going to ask our hash maps, do you have any 11 at any index? No. Then we are going to add it to our hash maps again. So we are going to add the 3 at the index 1. It will be go on until we see the index of one of those that we are actually trying to do. At the end, when we reach to the 12, we are calculating the difference between the target and the 12 there. So 14 is gonna be minus 12, it's gonna be 2. First of all, we are going to asking our hash maps, do you have any data inside our hash maps? And yes, we have 2 there. So at the index of the 0, then we are going to return back the index of the 0 and also the index that we already visiting. The index that we already visiting is 0, 1, 2, 3, 4. So the response will be 0, 4. With this approach, we will have the time complexity of O(n), but we're sacrificing the space. So let's jump to the code and show you how we are going to code it in Swift language. So now we are going to solve this problem in Swift language. As you can see, inside the question description, it is saying that there is exactly one solution for that. So don't worry if they give you a number target that will be not add up. So with that in mind, we are going to solve this problem with the approach that I described by using the hash map. So first of all, we are going to create our hash map, and our hash maps is gonna be 2 integers as the key and value, and I define it as an empty hash maps now. Then we just need 1 for here because we are going to iterate once inside our numbers or our array. So for I in 0 till our nums dot count, then we are going to asking our hash map if the value already there or not. Do you have any index of that value? So we need the current value. Let current val equal to nums I, and also we need the difference here. So let diff equal to our target minus the current val that we are now there. So current val, and now we have the different here. It's time to asking our hash map if you already have it or not. So we can asking our hash map by an if statement. If let index equal to our hash map, it means that we have an index already there, and else if it doesn't have anything, then we are going to populate our hash map with that data. So with the current val that we already on it now, and we equal it to the I, it means the index. But when we have the data, we can just simply return I, because the I is the current index that we are on it, and also the index that we get from the hash map. So the next one will be the index. And if we get out of our loop and we didn't find anything, we can just simply returning an empty array. So let me build the app and see the result. As you can see that this approach, by using the hash maps and sacrificing a memory space here, we are going to be more than 95% above other submissions for TwoSum now. So always think about it to when you can sacrifice the space regarding the time complexity, and always talk with your interviewer about such these situations. Be successful, like this video and subscribe to this channel to see more content like this. See you on the next time.